Next step in the design of an aqueduct is the head loss and bed level. Here we have considered different sections, section 11, 22, 33 and 44. The canal, as we mentioned earlier, it reduces from 30 meter to 15 meter after fluming. So where the fluming starts, where the canal is having a width of 30 meter, that is the first section, section 11, that is at the upstream side. Then when the flowing is completed, that means when the canal width becomes 15 meter, that is the section 22. So this is the part of contraction. Then after that, the canal width from 15 meter is increased to 30 meter, and that particular section is section 33, where the expansion starts. Section 44 is the section where the fluming is completed or the canal regains its width 30 meter. So altogether we have 4 sections, section 11, 22, 33 and 44. So here, when the canal is flumed and its width is reduced to 15, definitely there will be head loss because contraction take place. And depending upon the length of the trough portion from section 22 to 33, trough means the portion that carries water in the canal where cross drainage work is provided. So after the trough portion is over and when the expansion starts, again there also head loss is possible. So due to expansion and contraction, head loss in the canal is possible. So therefore we need to maintain the canal velocity such that its natural flow is always maintained. So first of all we are considering the first section, section 44. Section 44, we are taking the canal bed level at section 44 as 198 because it is given in the question. The canal bed level at section 44 is 198. So above the canal bed level is the height of the water, and it is given as 1.8 meter in the question. So at the top where the water surface is there, the elevation will become 199.8. that means 198 plus 1.8, which is equal to 199.8. Now if we are considering the total energy line, it will be above the water surface and the velocity head will be equal to v square by 2g. If we are adding that to the water surface, then we will get the total energy line. Here, since it is section 44, the velocity at that section we can say, or we can name it as v4. So therefore it is, the velocity head is v4 square by 2g. So to find the TEL, that is the total energy line, the elevation of the total energy line equal to water surface elevation plus v4 square by 2g. So if you know the value of v4, we can find the total energy line or its elevation. So then what is V4? Now next we want to find V4. So to find velocity V4, we are taking the canal cross section at section 44. Section 44 and section 11. The canal cross section is a trapezoidal section. Why? Because the canal which is coming from the reservoir in the upstream side and probably going to the field of the farmers in the downstream side, its usual section is trapezoidal section. So we are taking the canal section as a trapezoidal section. Also in the question it is mentioned it's a trapezoidal section. So for the trapezoidal section, the base width is B, or the width of the canal is B, that is which is equal to 30. Then we have two side slopes, and side slope, the slope given is, or we are taking is 1 vertical to Z horizontal. So 1 vertical to Z horizontal means, if we are taking Z is equal to 1.5, then we can try write instead of Z 1.5. That means here Z is equal to 1.5. So to find the velocity V4, we know that velocity is equal to discharge divided by area. Area of cross section at section 44 only. So what is V4? V4 is equal to discharge divided by area. Discharge in the question it is given, the discharge through the canal it is 25 meter cube per second. It is given in the question. So what about the area? Area, that is A4 at section 44, the area, this is the shape. So to find this area, we have three portions. One is this rectangle portion whose width is B and its height is the depth of water, that is equal to Y. So width B is actually 30 and the height of the water given in the question is 1.8. So 30 into 1.8. Then we have two another parts. The two other parts are the triangular part. First one is this and the second. These two triangles are similar. So we can multiply the area of one triangle with 2. So that means 2 into area of one triangle. Area of this triangle, if you take, it is triangle area half into height into base. So half into height, it is equal to Y, that is 1.8. Then the base we have taken Z is equal to 1.5. So into 1.5. So in short, to find the velocity, we are dividing the discharge with the area. So we are getting 25 divided by 30 into 1.8 plus 2 into half into 1.8 into 1.5, which is equal to 0.425 meter per second. So we got the value of V4 now. Our intention is to find V4 square by 2g, which is the velocity head. So to find velocity head, if we solve V4 square by 2g, we will get its value as 9.20 into 10 raised to minus 3 meter. So if we get the value of V4 square by 2G, we can find the value of total energy line. Total energy line is equal to water surface elevation plus V4 square by 2G. This one we mentioned in the last step. So TEL is equal to water surface elevation plus V4 square by 2G. So we got the answer as 199.809. So next, about section 3.3. Section 3.3, the total energy line is equal to elevation of the total energy line is equal to elevation of total energy line at section 4.4 plus head loss between section 3.3 and 4.4. Why it is like that? Because section 1.1 is at the upstream side and section 4.4 is at the downstream side. Section 1.1 upstream side and this is downstream side for the canal. So when water is flowing from section 1.1 to 2.2, then 2.2 to 3.3, then 3.3 to 4.4, each stage there will be loss of energy. So definitely when water is moving from 3.3 to 4.4, there will be loss of head, and that loss of head is due to the expansion here because it is expanded. So because of the expansion, energy loss occurs. So definitely the total energy line at the section 3.3 will be more than that at the section 4.4. Okay. So we need to find total energy line at section 3.3. This is our question. We need to find that. And we know the elevation of total energy line at section 4.4. We already know that. Now to find this, we need one more thing, that is head loss between 3.3 and 4.4. So what is the head loss between 3.3 and 4.4? So as we mentioned, this head loss is due to expansion. From 3.3 to 4.4, the section is expanding. So expansion loss, which is equal to 0.3 times V3 square minus V4 square by 2G. This is the equation that we have to apply. So to find this, do we know these values? Of course, we know the value of G, 9.8. This we know. And about V4 also we know. V4 we found in the last step. So we don't know what is V3. So V3 we don't know. So to find V3, we have equation V3 is equal to Q divided by A3, discharge divided by A3. Okay, so what is the discharge? The discharge is the same. Whatever discharge is passing through the section 1.1 is going to section 2.2, 3.3 and 4.4. Discharge is the same. The value is 25 meter cube per second, that we know already. Okay, right. Then what is the area? If you are taking the area, there is some difference. The area of the section at 3.3 is not a trapezoidal section. It is a rectangular section. At the trough portion, that is from 2.2 to 3.3, the shape is rectangular. So section 2.2, it is rectangular in shape. Section 3.3, the shape of the canal is rectangular. Okay, then what is the width? So this is a rectangle. So what is the width? The width is 15, because it is not 30, it is fumed with 15. So it is only 15. What about the height? The height is the same, the height is 1.8. That means we can find the area A3. A3 is equal to width into height. If we do, we can get the area. So A3 is equal to 15 into 1.8. A3 is equal to 15 into 1.8. Then we will get the answer 0.926 meter per second. 0.926 meter per second is the velocity at section 3.3. So we have all the values to find the expansion loss. We know the value of V3 and V4. And applying this equation, we got it as 0.0103 meter. So our intention is to find the value of TEL at 3, that is the elevation of TEL at 3. To find that, we can add the elevation of TL at 4 with the head loss that we found now, and we got the answer as 199.819 meter. That is the TEL of 3. So the total energy line at section 3.3 that we got now. Now we need to find the water surface at section 3.3. We know that if we subtract velocity head from TEL, we can find the water surface. So now we need to subtract the velocity head, that is V3 square by 2g, from TEL. Why we are taking V3? We are taking V3 because it is section 3.3, there the velocity we named it as V3. Okay. So now we can find it. Elevation of water surface at 3 equal to TEL at 3 minus velocity head V3 square by 2g. So do we know the value of TEL? Yes, we know the value of TL at 3. We found it now, 199.819. And what about V3 square by 2g? V3 we know, value of V3 we know. Already we used here. So V3 we know. And 2g also we know. So we can find the value of water surface elevation at 3.3. This line we can find. So we got the answer as 199.776. Then next our intention is to find what? The canal bed level. So if we got the value of water surface as 199.776, then how can we find the value of canal bed? That is this line. It is easy. Simple. We can subtract the value of water height from water surface. What is the height of water? That is 1.8. So if we subtract 1.8 from water surface, that is from 199.776, if we subtract 1.8, then we will get the value of canal bed. So we can obtain the value of canal bed also.